Hey everyone, welcome to the Slope and Graphing Linear Equations Guided Notes. Let's get started with some review. A definition of a unit rate. A unit rate is a special rate which compares a quantity to a single quantity. Zach hiked 6 miles in 3 hours. Determine the unit rate. How many miles per hour does Zach hike? If we want to determine how many miles per 1 hour, we can divide 6 miles divided by 3 hours. 6 divided by 3 is 2, so he hikes 2 miles per 1 hour. An equation you could use to determine how many miles m that Zach hikes in h hours. So I want my equation to be m equals, and if he hikes 2 miles per hour, then every hour will need to be multiplied by 2 to figure out how many miles. So the equation would be m equals 2h. Where do you see the unit rate in the equation? The unit rate is right here. That is also called the constant of proportionality. Graph your equation on the graph. A table is provided if needed. So let's say my hours are going to be 0, 1, 2, 3. Here's my equation right here. M equals 2h. Zach hikes for 0 hours. He goes 0 miles. 1 hour would be times 2, so 2 miles. 2 hours times 2 is 4. 3 hours times 2 is 6. So to graph this, my h will be on my x-axis, m will be on my y-axis. So I have the point 0, 0, 1, 2, 2, 4, and 3, 6. And then we will connect them to make a line. Now let's look where we see the unit rate on the graph. Create triangles on your graph showing that Zach hikes 2 miles for every hour. So Zach hikes 2 miles for every 1 hour. So 2 miles up for every 1 hour over. 2 miles up for every 1 hour over. And if you can see, I have these little triangles right here. The unit rate is the same as the slope of a graph in a proportional relationship. The unit rate of the graph is 2. The slope of this graph is 2. Let's graph more proportional relationships. Look at the following proportional table. So this table right here. What is the unit rate? So the unit rate is going to be what I'm multiplying x by to get to y. So if I have 3 and I need 1, I'm going to be multiplying by 1/3. And that's true for this whole table. So the unit rate is 1/3. Where do you see the unit rate in the table? And I can see it right here. That is what I multiply x by to get to y, the multiplicative relationship. Write an equation for the table. If I have x, I'm going to multiply that by 1/3 to equal y. So y equals 1/3 x. Where do you see the unit rate in the equation? Right here. It is also the constant of proportionality. Graph your equation and show the unit rate with triangles on your graph. So there's the table if you need to use that to graph. Here's my x-axis and my y-axis. I have the point 3, 1, 6, 2, etc. All right, so there's my graph. Now it asks me to show the unit rate with triangles on your graph. So my unit rate is 1/3. Well, for every change in y, I'm changing x 3 times. So every change in y, 1, go over 3. Every 1 up, over 3. So your triangles will look like that, 1/3, up 1 over 3. The unit rate of this proportional relationship is 1/3, and the slope of this proportional relationship is 1/3. Now let's look at the proportional relationship in y equals 1/2 x, right there. What is the unit rate of this relationship? The unit rate will be 1/2. I can see 1/2 as my constant of proportionality. Graph the equation on the graph and show the unit rate with triangles. This is a proportional relationship, meaning it's going to pass through the origin at 0, 0. If I don't know that, if I plug in 0 up here, I'm going to get out 0 because 0 times 1/2. Now, I'm actually going to draw my triangles first and then draw my line. My slope or my proportional relationship is 1/2, meaning for every 1 I go up, I'm going to go over 2. I'm going to go up 1, over 2, up 1, over 2, and I'm getting that from my constant of proportionality, so up 1 over 2. Now if you look right here, you can see the points on my graph. I'm going to just connect it and make a line. The slope in this relationship is 1/2, because remember they are the same in a proportional relationship, the unit rate and the slope. Practice. Graph the proportional relationships and show the unit rate and slope on the graph with triangles. Identify the unit rate and slope. So I'm going to do my triangles first and then do my line. So it says y equals 3x. That means my unit rate is 3 and my slope is 3. Now that doesn't have a denominator, so when it doesn't have a denominator, it's the same as 3 over 1. And so I'm starting at 0, 0, I go up 3 and over 1, and that is a point on my graph. Then I'm going to go up 3 and over 1, and there's another point on my graph. Up 3 and over 1, and there's another point on my graph. So I have the points on my graph, now I will connect them and make a line. Okay, let's look at the equation y equals 3/4 x. So my unit rate and slope will be the same in these relationships. So it's 3/4. We have xy. So if I'm starting at the point 0, 0, I'm going to go up 3 for every 3 vertical. For every 3 in the change of y, I'm going to go over 4. 1, 2, 3, 4. And that is a point on my graph. So I'm going to go up 3 and over 4. 1, 2, 3, 4. And that's a point on my graph. So now I connect those lines on my graph. Y equals x. Now there's a 1 right there. You can't see it. So it's saying y equals 1x or 1 over 1. So the unit rate is 1 and my slope is 1. So starting at the point 0, 0, I'm going to go up 1 over 1. That's a point on my graph. Up 1 over 1. There's another point on my graph. You can kind of start seeing the pattern here. Up 1 over 1. Another point on my graph. So these are all just going to be points right here on my graph. My triangles up 1 over 1, up 1 over 1. Now I'm going to connect the points to make my line. Slope and unit rate are the same in a proportional relationship. However, more generally, slope refers to the steepness of a line. Slope is a ratio. The numerator in the ratio is the change in the y direction. The denominator in the ratio is the change in the x direction. Slope is often symbolized by the variable m. We're going to summarize the slope in a formula. M slope equals the change in the y direction, and I can denote change by the difference or subtraction. So I'm going to say y2 minus y1 over the change in the x direction, which will be x2 minus x1. We will go into this more later, but notice that this is a point and this is a point. The sign of the slope helps to identify the direction of the line. Below we will sketch positive, negative, 0, and undefined slopes. Positive slope, the line will be going up. And that's if you're reading it like you're reading a book going this way, then the slope is going up. And negative slope, you can guess it's going down. Again, if you're reading it like a book, if you're going this direction, the slope is going down. That's a negative slope. A 0 slope is when it's just one horizontal line. It doesn't go up and it doesn't go down. An undefined slope will be a vertical line. Like that. So we have positive, negative, 0, and undefined slopes. Recall that slope is a ratio with the change of y in the numerator and the change of x in the denominator. Let's calculate the slope between 2 points, -8, -6, and -4, 2. So if I were to plot those points on a graph and connect the points to make a line, I want to figure out the slope of that line. The change in the y direction is, and I'm taking this y point right here, minusing this y point right there. So I'm going to say -6 minus 2. So -6 minus 2 is a -8. Now I did this point right here first, so I'm going to do this point first when I figure out the x direction. So -8 minus a -4 right here. -8 minus a -4. And that's the same as -8 plus 4. So -8 plus 4 is a -4. Therefore, the slope is the ratio of these two numbers. So the slope will be -8 over -4, which equals 2. Graph these points on the coordinate plane. Connect the points with the line. The calculated slope is positive. Verify that the slope looks positive on the coordinate plane. Okay, so let's do that. First, it asks us to graph these 2 points, -8, -6, and -4, 2. So I've graphed those 2 points and I'm going to connect it with a line. There's my line. Now it says the calculated slope is positive. So I determined that my slope is positive when I calculated it. And if I look at my graph, that is a positive slope because it's going up from left to right. So that matches. Here's a little caution that you might want to highlight. It says, when calculating slope, be consistent in which point you use first. So if I use -6 first in the numerator, I need to use -8 first in the denominator when I am calculating. Now let's determine the slope between the points -1, 7 and 5, -3. Calculate the change in the y direction. Again, it doesn't necessarily matter which point I start with as long as I'm consistent in both the numerator and the denominator. I'm going to put a 1 over here that I use that one first and then a 2 over here that I use that one second. I'm going to do the change in the y direction. So 7 minus this number right here, a -3. So 7 minus -3 is 10. And then a change in the x direction. So x -1 minus 5. -1 minus 5 equals a -6. The slope is the ratio of these two numbers. So we'll have 10 in the numerator over a -6. And that reduces, I can divide both by 2, so that reduces to 5, -3, or -5/3. I calculated that the slope is negative, right there, negative. So when I graph it, I know that it's going to be going down. Let's graph that on the coordinate plane. So I'm going to graph the points -1, 7 and 5, -3. So those are my points. And then if I connect the line there, that is a negative slope. So I know that my slope is at least going in the right direction. And here's another caution that you should mark. Attend to precision with the negative signs. Make sure you're watching those negative signs, especially with the subtract. Calculate the slope between the 2 points 8, 4 and -2, 4. So I need to figure out my change in y over my change in x. So again, it doesn't matter which point I use first as long as I'm consistent. So I'm just going to put a 1 there and a 2 there. So I know that I use this point here first. So we're going to go 4 minus 4. So 4 minus 4, and that equals 0. That's my change in y. And let's just do this like this. So I'll have my numerator there and my denominator on the bottom. So I'm going to use my 8 first because I used the 4 first. So 8 minus a -2. 8 minus a -2 is 10, because that's the same as 8 plus 2. So my slope is 0 over 10, which is the same as 0. So let's graph those points. I'm going to graph 8, 4 and -2, 4 on my graph. So those are my points, and now if I connect them to make the line, that's the line of those points. Remember that a 0 slope is a horizontal line, so that makes sense. 0 slope, and it is a horizontal line. Calculate the slope right here. It doesn't matter which points I use first as long as I'm consistent. So we'll just say 1, 2. I got to do my y's first. So 7 minus a -3. 7 minus -3 is 10. So that's my numerator. Denominator is going to be 5. There's my line. 5 minus 5. 5 minus 5 is 0. So I have 10 divided by 0. I cannot divide by 0. That means it's undefined. So I'm going to graph these points on the line and we'll see what it looks like. So there's the points 5, 7 and 5, -3, and I'm going to connect them to make my line. And my line is a vertical. Remember, that is my undefined slope, is a vertical line. Why does a vertical line have an undefined slope? The change in the x direction is 0. When 0 is in the denominator of the fraction, it will be undefined. Calculate the slope between the following points. Again, I'm just going to mark 1, 2. My change in y, so -3 minus 5, and that's a -8 over -2 minus -2. -2 minus a -2 is 0. So -8 divided by 0 means my slope is undefined. 1, negative 6, and 8, negative 5. We'll use this one first and this one second. I have negative 6 minus a negative 5. Negative 6 minus a negative 5 is the same as negative 6 plus 5, which is a negative 1 in my numerator. And my denominator is going to be 1 minus 8, which is a negative 7. Negative 1 over negative 7 is the same as 1/7. So my slope is 1/7. Mark my points. We'll use this one first. 1, 2. Again, it doesn't matter. My change of y is going to be 6 minus 6 over negative 4 minus 0. 6 minus 6 is 0. Negative 4 minus 0 is negative 4. So 0 divided by negative 4 is 0. So my slope is 0. Let's mark my points. 1, 2. So we have 7 minus a negative 1. 7 minus negative 1 is the same as 7 plus 1, which equals 8. And then we have negative 3 minus 1. Negative 3 minus 1 is a negative 4. 8 divided by negative 4 is a negative 2. So my slope is a negative 2. Recall that proportional equations are of the form y equals kx, with k being the constant of proportionality. All proportional relationships pass through the origin. Graph the proportional relationships on the coordinate planes below. My equation is right here at the bottom. It says y equals 3x. So I know that passes through the origin. And right here is my slope or my unit rate, which means for every change of y3, I go over 1. Every change of y3, I go over 1. And I know, look at this number right here. That's a positive number. So I know that my graph is going up, right? I just got to figure out exactly where. So here's my points right there, 3, 1. Now, if I happen to go down first, if this is a point right here, I know my point's got to be somewhere over here to make my graph go up. So if I'm going to go down 3, I've got to go this direction to get that next point. I'm going to go down 3, I'm going to go to the left to get that next point, to get a positive slope. Those are my points, and now I'm going to connect them to make a line. Y equals negative 1/2 x. I know it passes through the origin. And my slope, if I look right here, this is negative. I know my graph is going to be going down. It's going through the origin. I don't know what it looks like with my steepness, but I'm going to figure that out with my slope is negative 1/2. If I go up 1, I'm going to go to the left 2 because it's going to give me a negative slope. It's going to be going down. If I go up 1 over 2, right? Up 1 over 2. If I go down 1, I'm going to go to the right 2 because that way it's going to give me a negative slope. So down 1 over 2. So I can see my points on the graph, and I'm just going to connect them to make a line. Now let's graph y equals 3/2 x. It's positive right there, so I know it's going to be going up. Again, it's going through the origin. My change of y is 3, and my change of x is 2. So for every 3 I go up, I'm going to go 2 over. There's a point. Up 3 over 2, there's a point. Up 3 over 2, there's a point. Or if I go down 3, 1, 2, 3, I'm going to go to the left 2 to make the slope be positive. Now let's connect the points to make a line. There's my graph of y equals 3/2 x. Now graph the equations below on the coordinate plane. Tables are provided if needed. Okay, so let's use these tables to make a graph. So my equation is y equals 3x plus 1. So let's just use base of points of 0, 1, 2, and 3. So if I plug 0 in for x, 0 times 3 is 0, plus 1 is going to be 1. If I substitute 1 for x, 3 times 1 is 3, plus 1 is 4. Substituting in 2, 3 times 2 is 6, plus 1 is 7. Substituting in 3, 3 times 3 is 9, plus 1 is 10. I have my points right here, and I'm just going to graph it. So I have the point 0, 1, the point 1, 4, the point 2, 7, and the point 3, 10. Now let's connect the points to make a line. There's my graph for the line y equals 3x plus 1. Now I'm going to do a table for this equation right here, y equals negative 1/2 x minus 3. I notice that I'm going to be multiplying my x's by 1/2, so I'm going to strategically choose even numbers for my x's to make that a little bit easier. I have negative 1/2 times 0, which is 0, minus 3 is a negative 3. Negative 1/2 times 2 is a negative 1, minus 3 is a negative 4. Negative 1/2 times 4, that's going to give me negative 2, minus 3 is a negative 5. Negative 1/2 times 6 is a negative 3, minus 3 is a negative 6. So now I will graph these points in my table on my graph here above. I've graphed my points and now I'm going to create my line. There's my line for the graph y equals negative 1/2 x minus 3. Here's my equation y equals 3/2 x minus 4 we're going to graph. Again, I'm noticing I'm dividing by 2 with my x's, so I'm going to choose even numbers. I don't have to, it just makes it a little bit easier to work with. Substituting in 0, 0 times 3/2 minus 4 is going to give me negative 4. Substitute in 2, 3/2 times 2, well those would cancel, and that gives me 3 minus 4, which is a negative 1. Substituting in a 4, 3/2 times 4, well 3 times 4 is 12, divided by 2 is 6, so 6 minus 4 is 2. Substituting in a 6, 3 times 6 is 18, divided by 2 is 9, 9 minus 4 is 5. Now I will graph those points on the graph above. Those are my points and I will connect them to make a line. There's the graph of my equation y equals 3/2 x minus 4. Look at the graphs on the previous page. How does the line y equals 3x differ from the y equals 3x plus 1 graph? So let's flip back to the other page, and we are looking at these two graphs here at the beginning. This graph right here, y equals 3x, and this is the graph as y equals 3x plus 1. How do they differ? Well, notice that they do have the same slope, but this graph here at the bottom crosses the y-axis at 1, where this one crosses the y-axis at the origin. How does the line y equals negative 1/2 x differ from the line y equals negative 1/2 x minus 3? So let's go back. So these are my two graphs I'm looking at here in the middle. So notice again, they have the same slope. The only difference is where they cross the y-axis. So this top one crosses at the origin right there. This bottom one crosses at negative 3. How does the line y equals 3/2 x differ from 3/2 x minus 4? So going back, we're looking at these two graphs right here. We have this one and this one. Again, they have the same slope or like the same steepness, but where they cross is different. This crosses the y-axis at the origin, and this one crosses the y-axis at negative 4. How do you think the graph y equals 2x would differ from the graph y equals 2x plus 1? Let's go back up here. So we have 3x and 3x plus 1. They have the same slope, but the line y equals 3x plus 1 crosses at 1. Down here, this equation crosses at negative 3, and this one crosses at negative 4. So if I had 2x plus 1, I'm going to guess again that it's the same slope, but that 2x plus 1 crosses at 1. Okay, it asked me to graph the lines y equals 2x and y equals 2x plus 1 on the graph below. I can graph y equals 2x because it's a proportional relationship and it crosses the origin. My slope is 2 over 1. I'm going to go up 2 and over 1, and there's a point. Up 2 over 1, there's a point. I'm going to continue that pattern up 2 over 1 and get my points. Then I'm going to connect them and make a line. There's my graph of y equals 2x. So if I need to, I can make a table for my y equals 2x plus 1. So if I substitute in 0, 2 times 0 is 0, plus 1 is 1. If I substitute in 1, 2 times 1 is 2, plus 1 is 3. Substitute in 2, 2 times 2 is 4, plus 1 is 5. Substitute in 3, 2 times 3 is 6, plus 1 is 7. Okay, I'm going to graph those points on my line right here. Those are the points on my line. Now let's connect them to make my graph. That is the graph of my line, y equals 2x plus 1. So notice that they do have the same slope, and y equals 2x plus 1 is just shifted up by 1 on the coordinate plane. It asked me to describe the similarities and differences between the following equations. So y equals negative 6 and y equals negative 6 plus 3. These have the same slope of negative 6. What's different is where they cross the y-axis. This is going to cross at 0, and this one will cross at plus 3. Now let's look at these equations. Again, they have the same slope of 2/5, The difference between these equations is where they cross the y-axis. This one will cross at 0, and this one will cross at -6. Let's practice graphing linear equations. Let's start with the graph y equals -2x minus 3. The slope is this number right there, so the slope is -2. The y-intercept, where does it cross the y-axis? That's going to be this number right here, -3 or -3. The negative in front of the slope means that the graph slopes down, reading from left to right. Let's graph the line. We will start with the y-intercept of -3. So I'm going to go ahead and graph that on my y-axis. Remember, this is x and this is y. So it's going to cross my y-axis at -3. And I'm just going to plot that point right now. The slope tells us the ratio of the change in y over the change in x. The slope as a ratio is -2 over 1. Now if I look, I don't actually see my denominator right here, so I can assume that it's a 1 on the bottom. Let's move vertically 2 and horizontally 1. Remember, the slope is negative, so pay attention to the direction of your movements. So I know that my slope needs to be going down. Move vertically 2, because that's my change in y, and horizontally 1, that's my change in x. So if I go up 2, I'm going to go to the left 1 to get that point right there, because that's going to help my slope go down. If I go up 2 over 1, or if I go down 2, I'm going to go to the right 1, and that will also give me that negative slope. There's some points on my graph, and now I'm going to connect them to make a line. So it says, in this case, if you move upwards 2, you will move horizontally 1 to the left. If you move downwards 2, you will move horizontally 1 to the right. And it's just getting the idea of what direction I need my line to be going. Now let's graph the equation y equals 1/3 x plus 2. The y-intercept is this number right there, so that is 2. Graph the y-intercept on the graph, so there's my y-intercept. The slope is right here, 1/3. This means the change in y is 1 and the change in x is 3. So if you move vertically 1, then you will move horizontally 3. This is a positive slope, so the line slopes up, reading from left to right. Starting from the y-intercept, if you move upwards 1, then you will move horizontally 3. So I want my line to be going this direction, right? I want it to be going up. So if I'm going up 1, I'm going to go to the right 3 to make it go that way. Up 1 to the right 3. So it asks me, if I move upwards 1, then you will move horizontally 3 to the right. And if I'm moving down 1, I'm going to go to the left 3 to get that same slope. So I have some points on my graph. I'm going to connect them to make my line. There is a graph of my equation y equals 1/3 x plus 2. Y equals -2/3 x plus 5. My y-intercept is 5. My slope is -2/3. So I know my graph is going to be going down. So let's graph my y-intercept first at 5. And then graph some more points. If I'm going to go down 2, I'm going to go to the right 3 to get a point to help my slope go down. So down 2 to the right 3. Or if I go up 2, I'm going to go to the left 3 to get that same point, making my slope go down. There are some points. Let's connect them to make my graph. This is a graph of the equation y equals -2/3 x plus 5. Let's graph y equals 1/4 x minus 2. My y-intercept is -2. My slope is 1/4. So I know my graph needs to be going up. Let's graph my y-intercept first at -2. If I go up 1, I'm going to go over to the right 4 to get a positive slope. Up 1 to the right 4. Or I can go down 1 and to the left 4 to still give me that positive slope. Those are some points on my graph. Now I will connect them to make a line. This is a graph of the equation y equals 1/4 x minus 2. Now let's graph y equals -x plus 1. My y-intercept is 1. We can graph that right here. And my slope is a negative, so it says -x. So that's like saying -1 over 1. So my slope is -1. So my slope is -1, so it's going to be going down. So if I go up 1, I'm going to go to the left 1 to help me get a downward slope. Or if I go down 1, I'm going to go to the right 1 again to help me get the downward slope. So those are some points on my graph. I'm going to connect them to make a line. That is the graph of the equation y equals negative x plus 1. Now we have the equation y equals x plus 4. My y-intercept is 4. My slope again is going to be, so it's 1 over 1, so my slope is 1. My y-intercept is 4. We'll graph that first. I know my slope is going to be going up. So if I go up 1, I'm going to go to the right 1 to help me get an upward slope, up 1 over 1. Or I can go down 1 to the left 1, again, to help me get that upward slope. Those are some points on my graph. I'm going to connect them now to make a line. That is a graph of the equation y equals x plus 4. Okay, everybody, that's it for today. Thank you.